Thermon, and Peter is going to talk to us about Dyne IR heaters. I'm going to start sharing my screen. And you should all see my screen by now. I'm going to pull up Peter's PowerPoint. All right, can everybody see that?
Yeah, I can see it. It looks good.
All right, perfect. So without further ado, here is Peter Gomez. Peter, take it away.
Oh, hi, everyone. It's good to be with you here on the Friday morning, getting into the afternoon. I'm sure we're all looking forward to the weekend. I know I am. And appreciate the time you're giving here to attend this presentation. And give you a little bit of background. I've been with the organization for about 26 years. I started off in the catalytic side of the business. We manufacture a lot of different heating products, from catalytic heaters all the way up through explosion-proof unit heaters, electric unit heaters, and engineered products as well, to engineered systems that we offer to our clientele base. So there's essentially two sides of our business. There's the environmental heating side, which incorporates the Dynes, and as well there's a process heating side that we have, where we get into things like fuel gas conditioning skids, separation skids, some more advanced type systems. But today we're going to focus on Dyne. So my background is heavily based in the catalytics. I worked with our PhD Yarks and Karchuk for many years in developing catalyst technology that we've built into these catalytic heaters. Over the years, we've improved the efficiency and just improved the product overall to what we see today. So moving on to the next slide, I guess you'll have to control it, Andrew?
That's all right. Here we go.
I'm just going to give you a prompt. So when we talk about catalytic heaters in general, we're speaking of explosion-proof catalytic heaters today that are specifically used predominantly in the oil and gas industry. And when we talk about a catalytic heater, and I've got some slides coming up that'll show a better illustration of what the catalytic heater looks like and how it breaks down. But the heart of the heater, the heart of the product, is the catalyst. And in the slide here, it says a catalyst is defined as a substance that alters, accelerates, or instigates chemical reactions without itself being affected. And that's true. So we have basically a natural gas or propane that comes in contact with the catalyst. There's a catalytic reaction. It's an exothermic reaction that occurs within the catalyst, and it produces infrared heat as its main source. There are some byproducts to it, which we'll talk about in a little bit, but typically it's a chemical process that controls the rate of oxidization. And if you click to the next slide, we talk a little bit about how it works. And basically what you do out in the field, and I'm speaking oil and gas again, is you'll fire up the catalyst via a electrical element. So there'll be a low watt density element located in the casing of the heater, and that element preheats the catalyst to a temperature of 250 degrees Fahrenheit. Once that temperature is achieved, we then introduce gas into the system. The electrical component of it is shut off, and gas then takes over, and the reaction increases to a temperature of around 750 to 800 degrees Fahrenheit. But within that catalyst, you have two components. You have one, the initial catalyst, which controls the rate of oxidization, assuring that we're not overachieving temperatures, because we have to maintain our Group D classification. And also, we want to control, make sure that if there's any hydrocarbons or any explosive gases in the building, that catalyst actually consumes those gases in the reaction. So those are the two components of the catalyst. One is the rate of oxidization, and secondly is the ability for it to consume hydrocarbons in the reaction. So even though I've said we will achieve a temperature of, say, 750, 800 degrees Fahrenheit, some could be looking at it going, well, wait a minute, some of these gases that are in the facility have an auto ignition temperature much lower than that. The catalyst will never become an ignition source, rather it will consume the gases in the reaction. That's how it works. Now, the casing of the heater is metal. It's stainless steel. It does carry a temperature code, T2C, so we're okay as long as we're maintaining those temperatures on the casing. So next slide. So this is just a quick colorful slide of how the reaction works. So we have natural gas, oxygen, and of course IR, energy being the main byproduct of the reaction. H2O and CO2 are a couple other byproducts that come off the heater. No CO So we don't have any carbon monoxide. It's carbon dioxide, H2O, and IR energy. Okay. So we talk about the principles of infrared heat. We are dealing with the medium wavelength. We get into emissivity. We talk about dark absorption or dark objects. You know, some guys will put a catalytic heater close to their pipe, for example, or a regulator. And because it is fairly reflective, it doesn't absorb the IR as readily. So we encourage people, especially when you're pipe heating or you're spot heating certain areas, to have it a dark color. If you want to put a black paint on it or something like that, it'll absorb that IR energy a lot more readily. You'll notice when you walk into the building on a cold morning, the building may still feel chill, but you stand in front of the heater and you have your dark overalls on. You bend your leg, you'll feel it. I mean, your overalls will absorb that IR energy. So, next slide. So again, some of the byproducts of the reaction, H2O and CO2, as I mentioned, no CO or NOx emissions. When we talk about consumption, the heater requires 40 to 60 standard cubic feet of air per every square foot of heater surface area. So if you had a 12 by 12, 12 inch by 12 inch size heater, you're looking at around 60 standard cubic feet of air. So that's what's required. Sometimes we'll get into situations where we'll have such tight enclosures or tight buildings, we don't have enough airflow, the heater will snuff itself out. So we do need oxygen for it to run correctly. The other component, of course, is, and I say this tongue in cheek, but clean, dry, sweet gas with high BTU content. We're talking 1,000 BTUs per hour for natural gas, and of course 2,500 BTUs per hour for propane, which is the natural, which is the rated BTU calorific value on propane. So we want to make sure that we have as clean a gas as possible. Understanding that's not the case, especially in some of these remote locations where we're metering gas and such. We have ways of filtering the gas. We can use coalescers or desiccant filtration, but that's the recommended content of what we want to get optimal performance out of the heater. When we talk about contamination, we do talk about like water, H2S, sometimes oil. Now, oil is a hydrocarbon, and the catalytic heater will try to burn off that oil. But what you're doing is you're coating the chemical composition of the catalyst, so it's not absorbing, or absorbing is not the right word, but it's not seeing the oxygen as well. So you can get cool spots on the surface of the heater, and that will in turn, have a negative effect on the product overall. So we want to try to just keep the message is try to keep the gas as clean as possible, and we have ways of doing that. So the product design characteristics, when we look at a catalytic heater, flameless. It's a formulation of chemicals, as I mentioned, governs the rate of reaction, ensuring that the heater does not become an ignition source. Explosion-proof sealed electrical connections. So as I mentioned earlier, and we'll just go into a bit more detail here, when we start the catalytic heater, we're using an electrical element. So we do have a junction box on the back of the heater that's sealing the terminal ends. And the catalyst reaction consumes hydrocarbons. So here's a kind of a cutaway example of what the heater looks like. See, we have our thermocouple and safety shutoff valve on the back of the heater, the junction box, as I mentioned, the tubular element, and the catalyst pad on the front. We do have a variety of different levels of insulation within the casing that just act as filler, support the heater in general, and keep the back from getting too hot. And then a bezel and wire mesh on the top of the catalyst. But when we talk about the heater in the overview sense, what'll happen is we'll energize these elements. That tubular element you see there on the illustration, that'll hit that 250. There's a millivolt signal being sent constantly from that thermocouple to the safety valve. Once that catalyst preheat temperature is achieved, the signal's strong enough coming from that thermocouple to the safety valve that once you depress the button on the safety valve, there's a magnet inside that valve that holds the valve in the open position, allowing gas to flow through into the catalyst. So fuel enters back, fuel will enter through an orifice, a spud nozzle into the heater, and then it'll disperse throughout the heater and then react with that catalyst and increase that temperature to the optimal operating temperature of 750 F. So once we have a combination of fuel, oxygen, that preheated catalyst, we have the catalytic reaction going, life is good, we can unhook our electrical power, gas is flowing through, and then we can the heater will run continuously until either it becomes contaminated. And if it does become contaminated, the pad temperature will cool. That millivolt signal will lessen, for lack of a better explanation, and then the safety valve will shut off, and the heater will shut off completely. So that's kind of the premise on why we have the safety valve thermocouple set up on the back of the heater. These heaters are, I should add, CSA and factory mutual approved for Class 1, Div 1 and 2 Group D locations. So when we talk about the safety valve, one of the problems we see out in the field, and I'm not afraid to mention it, but guys will tie down that button on the valve. And the one thing we need to be careful of, and why do they tie down the button, is because they can override the thermocouple apparatus. So if the temperature starts to drop, customers might look at it and say, hey, I'm getting enough temperature out of the heater to justify its existence. So maybe it's 250, 300 degrees, and you're not getting that 750, 800 optimum temperature, but you're getting enough to keep what you need warm. But what's happened is the catalyst probably has been compromised by a contamination of some type, whether it be water or H2S or salt or whatever you have in the environment or in the gas line. And if you tie down the valve, it can override it and keep the heater running. So you'll see that in the field. It's a good opportunity to talk safety. It's a good opportunity to maybe sell a new heater or offer some options as it relates to maybe another safety valve, a thermocouple, if that has become compromised. But typically when you see that and people are feeling like they have to tie down the valve, it's because the temperature output on the heater has probably been compromised in some degree, and the valve's not staying open for some reason, which typically is the heater temperature output is not where it needs to be. So we do have tamper-proof valves where the button cannot be tied down, or if you do tie it down, it actually shuts the heater off. So we do have that option. But typically, this is the main thing you'll see on the heater that we need to really look at and focus on from a safety perspective. All right. So this is the typical gas train overview of what your heater will look like, starting with the main shutoff valve on the right-hand side of the screen. Then we'll move to an inline filter. We do sell and manufacture rather a line of filtration called our Flow Dry. It's a desiccant filtration. It's typically our G10 or our G25 would be the model name, and it'll go in line. It works on an impaction absorption method. There's a desiccant involved, so there's a chemical reaction within the canister that helps filter the gas. Those cartridges we sell will filter water, filter out water, oil, to some degree H2S. We do have calculation configurators that'll help you size the filter for the contamination in your line. Then we get into the service regulator, which is typically a Fisher 912, so it's a factory set regulator. It can be adjusted, but it's factory set to the 11 inches water column, or in this case in the US being factory mutual, be 4.5 inches water column. The appliance regulators for CSA heaters only. Typically you'll see that in Canada, or some packages that come down into the US from our Canadian packagers up there for oil and gas applications. You may see a natural gas appliance regulator involved that just drops your pressure down from 11 inches down to 4 inches based on CSA recommendations. And then we have a thermostatic controller, of course, the junction box, a safety valve, and the heater itself. That's your typical setup that we'll see out in the industry on a catalytic heater with its gas train. Okay. And then some of the product applications you'll see on the left-hand side of the screen, we're just the spot heating a regulator, and then we'll just get into straight facility heating. We'll do a heat load calculation, say, hey, you need 48,000 BTUs per hour in the building, and then people will install the heaters around their facility. We can build the catalytic heaters into line heating systems. So if we have town border station applications where we're getting pressure drops, we can address those through a manually controlled or an automated controlled system. Enclosure heating, gas preheating, anything that you see out there in the catalytic world, we can do as far as encasing the heaters in enclosures and applying them to product or to applications out there in the industry. So the big thing is, of course, spot heating and space heating. So a customer may say, hey, I have a a regulator that I need heated. It's in a building. We'll just size the heater to the regulator or to the filter or whatever you need, or to the sight glass, and then we'll install the heater accordingly. And then we get into space heating as well, where we just do a heat load calculation. We do have a sizing configurator on our website. Andrew or the team would be able to help size the heater. Myself, we can do that quite easily for you. And then when we get into applications, we're talking anything from separator facilities to compressors, wellhead shelters, meter runs, that kind of thing. So out here in Colorado and Wyoming, where I reside, we have a lot of space heating applications. We have a lot of buildings. Western Canada is very similar. A lot of buildings that need heating, whereas maybe down in Texas or Oklahoma, where we don't have the ambient challenges as much, we'll get into a lot more spot heating and enclosure heating type applications. Perfect. So just a quick slide on mounting and installing these heaters. I do safety seminars or safety schools for end user clients, and and I'll get asked the question, hey, how do I mount these heaters? Can I mount them vertically? Can I mount them straight up and down? Can I put them in a corner, face this way and that way? And the reality is they'll operate and work in most any configuration, but for the best optimal operational condition, to get the best temperature and performance out of the heaters, no more than a 45 degree from the vertical. We recommend not installing horizontally or face down, just because the temperature output will not be the same. It will be depleted. And we have some recommendations for mounting for space heating and spot heating. And again, back to that emissivity of the dark, dull black finish for best absorption. We talked a little bit about that. And of course, ensuring the unit is clear from wind and rain and things. Different model sizes. We manufacture these heaters from 6x6 all the way up to 24x72, 24 inches by 72 inches. Available in a variety of different voltages. We have, as you can see on the bottom of the screen, a variety of different configurations. So our MK2 is where we take all the accessory products, the junction box, the thermocouple, the safety valve, the serial plate. We mount it on the side. This was a customer demand rather than anything else, saying, hey, look, we're sick and tired of reaching behind these things, so we put everything on the side. There's no difference in cost from our standard back mount heater. So the side mount allows you to mount it against the wall or close to the wall, gives you more of a footprint in your building, and it's easier to work on. And then our WX, which is our slimline heaters, which is a thinner style, so better competes with our worthy competitors out there, such as Cata and Bruest. So you can basically slide theirs out and put ours in. That's what our slimline is for. Our WX series heater is a more efficient product, where a typical, say, a 12x24 is 12,000 BTUs per hour. WX would be at 8,000 BTUs per hour. Now, remember, on gas heaters, on furnaces and gas appliance heaters, we base everything on input. Okay. And then our BX series is our good old-fashioned, old-style heater that we used to build back in the day. We don't sell a ton of BX series heaters right now. Most everything is WXS and WX and MK2, but our BX series is our tried, tested, true heater that we've been building for years. And then just you can skip over that slide. I talked a little bit about it already. Yeah. And then some of the accessories we sell, of course, at this time of year, we're selling a lot of thermocouples and safety valves and ball valves and thermostats. But we if we're not manufacturing them, of course, we carry them in inventory and stock the product and sell them accordingly. But this is the time of year where we're selling a lot of these types of accessories. And then touch briefly on enclosures. We do have some custom enclosure products. We don't stock enclosures as much as we probably should. So the lead time can be a week to 2 weeks, just kind of a heads up. That's not to say that we couldn't stock product on the enclosure side, but there's a lot of customability to it, where if you have a rotary meter of a certain size or regulator of a certain size, we may need just some time to get the design right and and get it in place. But on the right-hand side of the screen, you can see some of our more standard type products. So we can custom build enclosures or offer our standard enclosure systems to our customers.
All right.
I tried to do that in 15. It was tough.
You did pretty good, I would say. 20 minutes, not too bad. Thank you for covering all that, Peter. I'm going to go ahead and unmute everybody. And while I'm doing that, I had a quick question for you. So I know that Thermon is a full process heating company. Is that right?
Correct.
So have you ever put one of these on a custom solution, sort of a small skid, and then sent it to a customer? Are there any applications that jump out at you?
Well, one we did for a DCP Enterprise Connection up here in Colbrand. We manufactured a catalytic line heater, which also incorporated a 3-stage separator and also a meter tube. So we can get into some pretty heavy customizable type applications. And when it involves catalytic heat, I mean, that's one component of it, but you can get into filtration and metering. And you can also on the catalytic heating side, depending on your, we could do another presentation on this completely, depending on your pressure drops and such. You can zone control your heaters in an oven type application through a line heater. And, it can get, I shouldn't say overly complex, but, you can get more complex than just a standalone in the corner of a building per se.
So I think what he's sort of referring to, this is a picture of the complete solutions that Thermon can do. And this is from a video that we did, but yeah, anything you need to heat, however you need to heat it, absolutely, we could do probably a week's worth of presentations just on all the different things you can use. And yeah, Thermon can create these custom products, and the catalytic IR heaters fit in with all of this. So
yeah,
just wanted to share that with everybody.
Yeah, are there any questions on the catalytic heaters and how they operate, work, some of the challenges you're seeing out there, anything like that from the group?
Yeah, so we've got a few people that are still on, and I allowed them to talk, but they might be having some connection issues. They seem to be connecting with the microphones. I think we've got one of them. Don, can you hear us?
I can hear you guys.
All right, perfect. So people are starting to connect, but Peter, I do think that at least where I come from in my territory, the vast majority is off of a pipeline or off of a oil storage facility, natural gas.
Mm-hmm.
And yeah, these go inside of the enclosure and they heat the little enclosure. Is that right?
So are you seeing these heaters in enclosures or are you seeing them in buildings?
I have seen them in buildings as well, but at wellhead stations, is that an application that you'd use them for?
Beautiful. Yeah. So the two common applications you'll see, of course, are enclosures where we'll have a stainless steel enclosure and maybe a little 6x6 or an 8x8, could be as big as a 12x12 inside the enclosure, and it'll wrap around the regulator, it'll wrap around the pipe, could be a pipe heater. There's that application, and of course, like on a wellhead shelter, it's a heater within a small building, keeping the wellhead shelter warm, keeping the wellhead warm. So you'll see both of those.
Yeah, I think those are the two most common applications. And what some people see, one reason that they've used these heaters is that I'm gonna share my screen again. Just they'll see this. They'll see what looks like hot spots. So right here on the wire mesh, with some other heaters, they've seen like there's spots that are hot and spots that are cold.
Okay.
And then when they put ours in, the whole thing seems a lot more uniform. Can you explain a little bit why that happens? Why that might be different?
Absolutely. So there's a couple reasons. One, the construction of the catalyst is a big part of it, right? So when basically the catalyst in general is about a 1/4 inch thick pad, and it's laced with a chemical composition, right? I call it the 11 herbs and spices. It's the proprietary chemical composition that makes up the catalyst that is applied on a cloth bed, if you will, ceramic fiber bed. And how that's applied is critical. As the catalyst is applied to that ceramic fiber, it will determine how it will react with the gas, for the lack of a better way to explain it. And as we fire the heater up, if the catalyst is applied correctly, you'll get even surface temperature across the catalyst pad.
So, Peter, you're talking about this thing right here. I got my mouse over it. Catalyst pad.
That's correct.
We have our special 11 herbs and spices. That's unique thermon.
Yeah.
And is that what you're saying can produce even heating?
Yeah, that's where you get the even heat from, is that catalyst pad. But here's the thing: in the old days, when you used to agitate or mix these things in a vat, if you will, you wouldn't maybe not necessarily get the even heat, right? You'd get enough heat to justify its existence, but you'd have some spots that were registering 750, 800 degrees, some spots that were registering about 500 degrees if you put an IR gun at it. So to get the even surface temperature really comes down to how the catalyst is applied to the substrate, if you will, for lack of a better term. So we need to be careful when we're reading temperatures, though, that we make sure there's no contamination, because you can get cool spots from that while it's in operation. So if the heater's installed and say a year or two's gone by, you go by and you say, hey, half the heater is warm, half the heater's cold, or I have cold spots here. That's a sign for the heater either needing to be replaced or repaired, because what will happen is gas comes through, contacting with the catalyst bed, and as that catalyst becomes compromised in spots and areas, because it's just seeing the gas as it is, you can get cooling temperatures off if the gas is contaminated and it starts to hit certain areas of that catalyst pad. It may not react, or certain spots may not react with the gas as well, and you'll get cooler spots coming off the surface of the pad. And that explains why you'll see, hey, I've got 800 degrees here and 200 degrees there, or 700 degrees here and hardly any temperature in this other area of the catalyst pad. I wish I could show you more definitively how that looks, but you'll see that out in the field. And remember when I said the catalyst will not become an ignition source, but you may have spots, cool spots in the heater that are allowing gas to slip through into the building. So that's why we want to make sure that catalyst pad is working optimally from point A to point Z.
Okay.
Does that answer the question?
Thank you. Yeah, that answers mine. And I think we are just about out of time. So Peter, thank you very much for doing this. We really appreciate it. And for everybody that joined, thanks. Tune in next week for a presentation on Coriolis meters, Yokogawa Coriolis. But thanks for coming. So see you later.
Thank you, everyone.